So this video is going to be on parallel and perpendicular lines. Perpendicular lines. So firstly, before we even define what parallel and perpendicular lines are, let's recall what our standard equation for a line is. So this is just any random line. For any linear graph, we have the relationship in standard form as y is equal to mx plus c. Alright, so this goes for any line where m is the gradient and c is the y-intercept. Now for parallel lines, parallel lines are defined as two lines which have the same gradient. Okay, so if the gradient of this line was to be measured against this line, it would measure the exact same value. So the way we define parallel lines is that the gradient of the first line is equal to the gradient of the second line, such that m1 equals m2. Okay, that's just the short definitions for this. So let's just say, for example, if I was going to compare the graph y is equal to minus 4x plus 2, a line that would be parallel to this line would be, for example, y is equal to minus 4x plus 4. Okay, and that would hit somewhere up here, and that would have the same gradient. Or, for example, y is equal to minus 4x plus 1, which would fall somewhere around here. Or if you want to extend this to the negative axis, it could be as simple as saying y is equal to minus 4x minus 100. Now if you look at the key characteristics between each of these lines, the key characteristic is the fact that they all have the same gradient. And so no matter which graph you draw, so if you draw this graph on the same Cartesian plane as this one, as the same as this one, as the same as this one, what you'll notice is that you'll just get a series of lines that look like this. So lines that are all parallel to each other. Okay? So parallel lines are lines that never meet. Just so you remember that from your definition. Okay? Now, let's look at a definition of a perpendicular line. So a perpendicular line, a perpendicular line is a line. Okay, so if we've got our line here, for example, going up like this, our perpendicular line would be a line that intersects this line right here at a 90-degree angle. So you can see here, it intersects at a 90-degree angle. So this red line would be perpendicular to this blue line. Okay, and the way we define perpendicular lines is such that the gradient of the first line is equal to, the gradient of the second line, it doesn't really matter, the second line is equal to 1 over minus m1. This might look a bit confusing at first, but if we plug this into something, we'll understand how we can get perpendicular lines from this. Okay, there's another way we can define perpendicular lines. The gradient of the first line times the gradient of the second line that is perpendicular to it should equal minus 1 if they are perpendicular. Okay, so for example, if I have a gradient where, for example, this line right here, the gradient for this line is equal to, let's say, 3, and I want to find out what the gradient of this line is. So this gradient is m2. So what I would do is I would plug it into the formula. So step 1, plug it into the formula. What is the formula first? m1, and that's the same as saying m2 is equal to minus 1 over m1, and m1 in this case is 3. So the gradient of the first line is 3, but the gradient of the second line is minus 1/3. Okay, that's how you find perpendicular lines. Now let's do an example. So an example that I have is you've got 2 points. You've got minus 2, 2, and 4, 8. Okay, and you want to find an equation for the 2 points. And the next thing is prove it is parallel to y is equal to x plus 10. So these are the two parts of the question. Find an equation for the 2 points, prove that it is parallel to y is equal to x plus 10. So I'm just going to quickly change color here. So if you remember from previous videos, to find an equation, first we need to find the gradient. Okay, so I'm going to label this as x1, y1, x2, y2. And to find the gradient, we use the formula m is equal to y2 minus y1 over x2 minus x1. And so in this case, y2 is 8 minus y1 is 2 over 4 minus y1 is minus 2, so don't forget to put the minus 2 minus 2. And so this is the same as saying 6 over 6, which is equal to 1. So in this case, we know that the gradient for these 2 points is equal to 1 equals m. Step 2, sub into line formula. So the line formula, if you recall, was y minus y1 is equal to m, brackets x minus x1. So let's substitute our values into this now. What is our value for y? That stays the same. What is the value for y1? If you look back to this question right here, y1 is 2 is equal to, what's the value for m? 1. What's the value for x? That stays as it is, minus x1, which is minus 2. Don't forget to put the brackets around these minus 2's, okay, because this can determine the sign of the actual number as soon as you expand it. So let's keep going on with this working. Y minus 2 is equal to 1, x plus 2. So we get here y is equal to x plus 4. So this is our second line, and we have managed to find an equation for the 2 points. So the 2 points, these 2 points right here will indeed pass through using this equation. So this equation will look something roughly like this, where it starts at 4, okay, and it hits, let's just say, for example, here, that this will be minus 2, 2, and this will be 1, 2, 3, 4, so this will be 4, 8. Okay, that's 4, that's 8. So it says here, prove that it is parallel to this. Well, this graph right here, m1 is equal to the gradient of this graph is equal to 1, and the gradient of this graph is equal to 1. Therefore, since m1 equals m2, they are parallel. Okay? So that concludes that specific example. Now we're just going to go through one last one, and this last example is you have the points minus 4, 1, you've got the points 0, 4. Okay, first thing you want to do, find an equation that passes through these points, and the next thing you want to do is prove, yes, I picked up on my spelling error from the previous slide, prove y is equal to minus 4 on 3x minus 2. So first thing is we need to find the equation of the line for these 2 points. So to find the equation of the line for these 2 points, first step, find the gradient. M is equal to y2 minus y1 over x2 minus x1. So this is going to be x1, y1, x2, y2. So what's the value of y2? 4 minus y1 is 1. What's the value of x2? 0. What's the value of x1 minus 4? So this should equal 3 over 4. So m1 in this case is equal to 3/4. But we don't stop there because we need to second use the line formula. So y minus y1 is equal to mx minus x1. So substitute everything in. Y minus y1 in this case is 1 is equal to m is 3/4. X minus x1 in this case is minus 4. Expand everything out, so y minus 1 is equal to 3/4 x, and that's positive, so this becomes plus, so that becomes plus 12 on 4. And so now if we simplify this, minus 1 is equal to 3/4 x plus 3, y is equal to 3/4 x plus 4. So this is the equation of our line. So if you want to look at this sort of like from a theoretical perspective or a graphical perspective, the line will hit somewhere at 4 and it will be a positive gradient. And so somewhere along these lines, okay, is 0, 4, which is right there, and somewhere along these lines will be minus 4. So minus 4 would be here, and minus 4, 1 would be there. So you can see these 2 points, if you join them up, what you get is a straight line. From here, we just need to find this last bit, prove that this is parallel, perpendicular. Okay, so in this case, m2 is equal to 1 over m1 negative. So m2 should equal to 1 over 3/4 and then negative. And remember, this is the same as saying minus 1 over 1 divided by 3/4. Now there's a cool trick you can do with dividing fractions. You can just keep this, change this, and then flip this. So this becomes minus 1 over 1, change it to a times, flip it to a 4 over 3, and so this becomes minus 4 over 3, which is your value for m2. Okay, and I'm about to run out of time, but you can conclude with, since m1 times m2 equals minus 1, so I'm going to do this here, m1 times m2 is equal to 3/4 times minus 4/3, that's equal to minus 12 over 12, that's equal to minus 1. Therefore, these two lines are perpendicular to each other.